All right, today we are going to continue looking at exploring quadratic graphs. And we are going to state the vertex and write equations, but we are also going to continue to identify which equation goes with which type of graph. So that's where I want to begin. So if we would look at this first example here, we are trying to match each equation with its graph. And when you do this, I want you to think about those properties that we talked about and looked at yesterday with respect to how wide or narrow a graph is and whether it opens up or down. So when we look at these four pictures here, we look at these four pictures and try to determine which is which. So when I start with, I guess number one, I'm going to start here with this equation. So this here is my parent function. All right, so I'm going to write, if I can, parent function. I'm just going to write parent next to number one. And so I am looking for the parent function here for A, B, C, or D. So I see that it is going to be opening up. And so if you can zoom in on well, you can't zoom in on this video, but let me zoom in for you. So when I look at this, no, it's not real, it's a little bit blurry. But if I look at, I'm going to put a dot right here. That is at the ordered pair 1, 1, and then another dot about right here is at the ordered pair of -1, 1. Okay, and so if we compare that to our parent function, if you have the, let me highlight here, if you have the x value being 1, and you plug it in here and you square it, you get 1 again. If you have the x value of -1 and you plug it in here and you square it, you get +1. So letter D is going to be our parent function. Okay, so that goes with letter D. All right, so if we look at the other three, I have a negative A value, or we'll talk more about, a negative A value. We have already discussed the letter A. I have a positive A value and a positive A value. And if you look at the three you have left, you've got two that are opening up and one that is opening down. So what I can determine is the only one opening down has to go with this negative A value. Okay, so I am able to say that number 2 is A. So I am now left with B and C. They both open up, which matches positive and positive, but one is much more narrow, one is wide. And so you have to go back and ask yourself, well, is the 3 produce a narrow or does it produce a wide parabola? And so if you do not remember, you can go back to that first section of notes, that the bigger the number is, of course, we're talking about the absolute value, the larger the absolute value, the skinnier it's going to get. So I am going to put B with number 4, which means when a number is in between 0 and 1, well, the absolute value of that number, it is going to be real wide. Okay, so those would be our 4 matching problems, and that is all based on properties of that A value. All right, next couple examples, we are going to focus on vertex. So looking at the tables below, state the vertex. So I just want to remind you that, remember when we made our tables yesterday? So if we were to make our own XY table, do you remember how we would put, we came up with the vertex and we would put the vertex here in the middle of our table, and then we put 2 numbers below it and 2 numbers above it. So I would maybe have -1, -2, and then 1 and 2. So I am always going to look for or have my vertex in the middle here, because remember, when you graph that parabola, it has symmetry. So on the right-hand side is going to be symmetrical to the left so that if I folded it over, it would match. So when I look here, what I notice is I see that these two numbers are both 2, and I see that these two numbers are both 8, which gives me that symmetrical pattern. So what that tells me, let me try to get a different color here. What that tells me then is that here is my vertex. Maybe yellow wasn't the best color, but that will work. So here is my vertex. All right, so when I look at the next example, there is a 5 and a 5 on either side of the 3, 11 and 11 on either side of the 3. So that means that my ordered pair of 1, put just a V maybe for vertex, the ordered pair of -1, 3 is going to be that vertex. Okay, so you're looking for symmetry. And I'm going to maybe add here, I'm going to write the word symmetry. All right. Okay, let's move on. We only have a couple more examples. And what we are going to do for these last 2 examples is actually write out the entire equation instead of being provided it. So this one says that for each graph has an equation in the form of y equals ax squared. All right, so we're going to write our equations in that format. The ordered pair is a point on the curve. So here's that ordered pair. Find the a value and write the equation for each function. Okay, so I am starting with this format. I get the hang of this. Let me try to make that a little bit better. Let me just start over here. So start with your y equals ax squared. Okay, so that's what I'm trying to plug into. So I need to come up with what number is the a value. All right, so what I'm going to do with this is notice the only things I have not highlighted now are an x and a y. Okay, but then if you think about it, what variables do numbers in ordered pairs represent? Well, they represent an x and a y. So what I'm able to do is come over here and substitute the ordered pair -2, 8 in for x and y. So if I have, I'm going to switch around colors here. If I have 8 is y, I'm going to plug 8 in right there. Okay, and so I'm going to be able to do 8 equals. So I don't know a. I'm going to figure that out, but I do know that -2 represents x. So let's plug that in, and then we can finish out that equation. So now I just solve for a. This is just an equation where I'm missing one piece. So let's take -2 and square it. All right, so I have 8 equals a, and I'm going to keep it in parentheses for a minute. -2 squared is 4. Now to make it a little bit easier to work with, let's switch around the 4 and the a. So let's actually view my equation like we normally would see it. Okay, so we normally would have the number come in front of, oops, my screen keeps turning, the number in front of the variable. So let's solve from here. Okay, so let's divide by 4. And so 8 divided by 4 is 2. All right, so now that I know it, I can come back up to the original equation right here, and let's substitute 2 right here, and then I can write my final equation. So the answer to this problem, or the answer for the parabola, the equation would be read y equals 2x squared. Okay, and then that is my equation. So all we're doing is finding a. If we know an x and then we know a y, we can substitute that in. All right, I want you to go to the next example, the last example, and I want you to pause this video, and I want you to go through this same process, and I want you to write the equation of the parabola in the next example. Okay, hopefully you have worked out your answer. I'm gonna, again, start with the format y equals ax squared. Here's your x and your y. So I'm going to plug -8 in for y, a is your variable, x is going to be 5. All right, let's simplify down. I'm going to do 5 squared. So I've got negative 8 equals a times 25. Of course, I'm going to switch it around. I'm going to call that 25a. Divide by 25 because you're solving for a. Okay, that way those guys cancel. And then negative 8 divided by 25, that's a decimal. In fact, let's divide that out and see what do we get on that. Oops, let me get my calculator going here. So negative 8 divided by 25 is 0.32, but I'm going to leave it as a fraction. So I'm just going to leave negative 8 25ths as my a value. All right, so my answer over here, I'll just come over to the blank. Y equals negative 8 25ths x squared. And there is your equation. Now I want you to notice two things. I want you to notice that the a value is negative and my parabola is opening down. And I also want you to notice, so we just said a second ago that number was, what, negative 0? I said it was negative 0.32. Well, 0.32 is in between 0 and 1, and I want you to notice that it's a little bit wider than our parent function. Okay, so those two items match up. All right, if you have any questions, please let me know.